Hello students, how are you all? Welcome to the class. Students, today we will discuss a new topic of force, pressure and motion, that is distance time graph for non-uniform speed or changing speed. So here you are seeing that this one is curved and how to draw distance time graph. So here you will study. Third one is distance graph when the object is stationary, that means that is not moving. So here you know that after interval of certain distance, when a moving object stops moving, becomes stationary, then the distance traveled by it does not change with the time and it remains the same or constant. The distance time graph of an object which stops moving becomes stationary is a straight line parallel to the time axis, that is denoted on x-axis as shown by the AB in figure here 2.15. You will see here when an object becomes stationary, its speed is 0. So the here a straight line graph parallel to the time axis, it's shown that the speed of object is 0. Here you are seeing here it is shown that the distance here the graph shows the 0 speed. And next one, the distance time graph of a stationary object is a horizontal line that is indicated by AB. Thus the straight line graph parallel to the time axis tells us that the object has become stationary. How to draw distance time graph? So here an example is given. The distance traveled by a car at various time is shown here, distance 0 to 5 kilometer and the time 0 to 5 minutes. You will draw solution. We take the graph paper here and draw a horizontal line OX on x-axis and vertical line on y-axis. Here you are seeing that these are its axis. So now here in this case write time minimum on x-axis and distance on y-axis, that is given here. And in this problem we have only small time value, so represent, so the scale to be used showing time, and it can be 1 minute is equal to 1 centimeter. You will take it, you will hypothesis these things that 1 minute is equal to 1 centimeter. We mark the time value 0, 1, 2, 3, 4 and 5 on OX axis. Okay, so this one is the OX axis and this one is Y axis. You will indicate these things, and after that again the distance value given in problem are small, 0 to 4 and 5 kilometers. So the scale to be used for representing distance values on the graph, it can be 1 kilometer is equal to 1 centimeter. We know marks of distance value, that is 0 to 5 on OI, and the first reading given in this problem is time 0 and distance 0. The point O represents the 0 value both of time and distance. You can observe it in the given graph. Thus a point O on graph paper, time is 0 at distance is also 0, and the second reading time is 1 minute and distance 1 kilometer. Now vertical lines above, the 1 minute mark on graph paper and the horizontal line on the side 1 kilometer mark on graph paper. Here cross, you will cross at point A, so we put a pencil dot at point A. Similarly the third, fourth, fifth and sixth reading you will find, and the corresponding reading of distance will give up B, C, D and E on the graph paper, which are marked as pencil dot. You can see here in the given diagram. Here you will observe these all the things. Now students, after that here you will observe we join the point O and the dot at point A. Here is the point O and dot A. When you will join these things, what will you find? B, C, D and E with pencil lines, that means A to E, you will join like this. We will get a straight line graph of OE. This is required here distance time graph for the motion of a car. Since the distance time graph for a motion of a car is a straight line, so we could here we conclude that the car is moving with the constant speed. That means car is moving on uniform speed. Here you are seeing an equal arm balance. So the mass here, the mass of body is commonly measured by an equal arm balance. You are seeing in this figure, and the SI unit of mass is kilogram when it is written in short as kg. It is very important. Then next one is weight. The earth attracts every object toward its center with certain force which develops on the mass of the body and the acceleration due to the gravity at the place, and that is weight. So the weight of the body is the force by which the earth attracts it toward the center. Okay. Now in other words, you can say that the force of earth acting on a body, that is known as weight. So we know that the force is equal to the mass into acceleration. Here force is equal to mass into acceleration due to the gravity. So F is equal to mg, and since that object to which that earth will attract, that will be from any height it will come. So here weight you will find only with the W is equal to mg, and weight is measured in the same unit as force is measured. So SI unit of force, that is Newton. So here, so SI unit of weight, that is also written as Newton, on which denoted by the letter N, capital N, and let us calculate the weight of 1 kilogram mass. So how will you calculate this mass? We will discuss in our next video. Till then, thank you everyone.